This media presentation will demonstrate the effect of bilging of midship compartment on intact waterplane area. A ship with a midship compartment is floating on an even keel. The volume of the compartment is V cubic meters. The midship compartment is bilged below the waterline. Bilging occurs when the hull breach is large enough to allow the free flow of water into the compartment and vice versa. Breaches which are too small to allow the free flow are not considered to be bilging. Once the midship compartment is holed, the buoyancy provided by this compartment of V cubic meter is lost. The vessel has to either regain this buoyancy or sink. If the buoyancy is not regained, the vessel will sink. Our bilged ship begins to sink. As she sinks, the hull sections forward and aft of the midship compartment begin to add to the volume of water displaced by the vessel. Once the added volume of water equals the lost volume of water, V, the ship stops sinking. The regained buoyancy, V sub 1, equals the lost buoyancy, V. It is possible to calculate the amount the vessel sinks, or sinkage, to regain the lost buoyancy. For this, we require to understand the term intact waterplane area. This media presentation will illustrate the concept of intact waterplane area. Consider a ship with a midship compartment that has a watertight flat 1 meter, 3.28 feet, above the keel, in other words, double-bottom tank. The dimensions of the compartment are L and B, floating on an even keel. A bird's-eye view of the waterplane will allow us to decide whether the waterplane area of the midship compartment is lost or not. In normal condition, the view of the waterplane is like this. There is no loss of waterplane area. In this scenario, the midship compartment is holed below the waterline, but above the watertight flat, and the compartment is flooded up to the waterline. The view of the waterplane is now like the midship section of the waterplane that represents the midship compartment has water. In other words, that section of the waterplane is lost. Intact waterplane area is normal waterplane area minus L times B square meters, square foot. In case the compartment bilged has permeability, P, as explained in the earlier topics, then the lost waterplane will also be reduced by this value of P. Hence, the formula will now be intact WPA equals normal WPA minus L times B times P meters squared, square foot. In this scenario, the midship compartment is flooded below the watertight flat. Water floods into the compartment below the flat, but further ingress is restricted by the watertight flat. The view of the waterplane is like we are unable to see any water since it is restricted by the flat, in other words, tank top. No waterplane area is lost. This media presentation will illustrate the effect of bilging of end compartment on trim of the ship. A ship is floating on even keel, and hence the COG and COB are lying in the same vertical line, which is not necessarily amidships. A compartment located at the forward end is bilged. In other words, water has entered the compartment from below the waterline. The water entering the compartment will rise up to the water level outside the ship. The part of the compartment which is now filled with water becomes part of the sea and is not part of the ship anymore. Hence, the underwater volume of the ship is reduced. To regain this lost volume, the ship will submerge such that the final underwater volume remains unchanged. In other words, the draft will increase, but the underwater volume and the displacement of the ship will not change. However, the shape of the underwater volume will change, which will cause the COB to shift aft, because it is the geometric center of the underwater volume. COG will not shift because there is no change in the displacement of the ship. Hence, a couple is formed between the forces of gravity and buoyancy, which will cause the ship to trim by the head till the COB and the COG are again in the same vertical line.